When carbon fiber material was developed, it opened up a whole new world of product innovation. In this video, we'll explore the science behind carbon composites and how carbon innovation redefines many of the products we use today.
A good way to think about a composite is where you get two different materials to cooperate with each other and give you something else that performs at a higher level. One very basic form of a composite is something as simple as plywood, where we take wood, run the grain at different directions, and then bond the whole thing together with resin to create a structure that's stronger and sometimes lighter than the original wood. Composites actually have a very long application in the human condition, from the mortar of the pyramids all the way through to today's jumbo jets.
Well, composite is basically two materials or more that are combined to achieve some sort of structural goal. So in our case, we're combining a carbon or glass or some sort of fiber with a matrix material, which is a resin.
So when we talk about a structure that's made with carbon fiber, something's got to hold those carbon fibers together. That is generally the resin. Generally, in sporting goods, you're going to find epoxy as the resin system that's used to hold the fibers in alignment, both in the axial and the radial directions. This is, of course, dependent on the specific application. For a baseball bat, you might have a high resin content carbon because it's tougher that way. For an arrow shaft, you might have a lower resin content carbon because lightness and strength are more important. Depending on the application, you can have various amounts of resin to carbon or a ratio that will provide you with different characteristics.
We make arrows. We use epoxy resin to make the composite. So to combine all of our fibers, whether it's carbon or whether it's aluminum to the carbon, we use an epoxy resin. And we use epoxy because it's super strong and it helps to give arrows their superior strength and to ensure good quality and good straightness.
Carbon fiber, as generally used in industry today, starts with what's called a precursor. The precursor is a material called PAN, or polyacrylonitrile, sort of like rayon. The rayon is taken through a long oven, about 5 miles long in fact, and it is pyrolyzed. That is, it is heated in the absence of oxygen. By the time it gets through that whole process, you have aligned carbon molecules that provide for the highest specific strength material commonly available today. We call it carbon fiber.
Carbon is an inherently expensive material, so usually it's used in the higher performance applications. Carbon fiber is a very lightweight, strong material, so it's a great choice for various applications like race car parts. You might see a wing, an airfoil, something like that. Or even structural components like in the frame, the vehicle itself, airplane wings.
So carbon is an element on the periodic table, but it's manufactured by burning away everything else that would be connected to it. And then throughout that process, you either turn it into a tow, which would be a long strand, or you weave it into a sheet.
Carbon fiber comes in a lot of different forms. It comes in a pre-preg, which is like a roll of fabric, where the resin is pre-impregnated into the fiber itself, thus the name pre-preg. It also comes in a tow type of a form, which is like, if you can imagine, thread on a spool. And that's the way we use it with our ACU Carbon process. The carbon comes in without the resin in it, in a dry form. From there, it goes through our machines, in through the resin, and then into creating the arrow.
Carbon is used anywhere where it makes sense to have the lightest, strongest structure available. Today, you see carbon used in things like air tanks of firefighters who want to have lighter weight gear to be able to go in to fight battles with fires without having the burden of having a heavy steel tank. The carbon tanks are able to hold the same pressure, but be a lot lighter.
So when you're deciding on what material to use, even just outside the broader spectrum of carbon fiber, you're going to be balancing strength and weight.
So modulus is basically a stiffness rating of the material. It also has to do with weight and strength to weight ratio, but in our case, a higher modulus is essentially a stiffer product that you can reduce weight with.
So in a similar way of why people will pick titanium over steel for certain applications, you're going to pick high modulus over low modulus in a similar way of, if I can get away with weight not being a very big issue. I can have whatever weight that I want. I just want it to be really durable. I could go down to a lower modulus, but in those applications where I need my weight to be as low as possible or I need the product to be as stiff as possible, generally you're going to drift towards that higher modulus the same way.
At Easton, specifically with our ACU Carbon process, we don't grind any material off the arrow. And so because the arrow is the same shape that it starts to when it finishes, we have to use specific modulus of fiber to achieve a certain spine that we're going after. If we need it stiffer, we have to use a higher modulus fiber to make the arrow stiffer.
We use modulus to explain how stiff a material is relative to another material. For example, wood has a modulus of about 5 million. Aluminum has a modulus of about 12.5 million. Our carbon fiber can have modulus in excess of 50 million. This would be for all the same mass weight. So as you can tell, carbon fiber is a lot stiffer for a given unit of weight than, say, wood would be.
So generally a higher modulus has less tensile strength, so it's more brittle. So it may be more stiff, but it takes less load. The lower modulus fiber generally has a higher tensile strength, so it can take more load, but it's not as light as a higher modulus carbon. So depending on what your end attributes you're chasing for will depend if you use a low modulus, an intermediate modulus, or a high modulus fiber, or some combination of those to get to your end result, what you're chasing for.
You know, when it comes to carbon fiber, there are a lot of different choices in both construction, in terms of how it's either a unidirectional material or a woven material. There are many choices in terms of how stiff the material is. There's even choices as to how much resin relative to carbon you may have in that structure. As rules of thumb go, the more resin you have, the tougher the product will be. The less resin you have, the lighter the product will be. The stiffer the carbon, generally, the weaker the material will be. But when an engineer sits down to decide which characteristics that product needs to have, he's got a wide library of products to choose from. You wouldn't necessarily use, for example, a woven material to make an arrow shaft that would go through a lot of flexing, because a woven material, over time, actually can break down in between the fibers in the weave. And so as a result, an engineer might not choose a woven material for some applications in an archery arrow. It might be better for some other applications in a thicker structure like a bow limb. There are many choices available for engineers today, and one of the keys to being a good designer is understanding which material to use for which application.